Good morning, class. We are on our second topic for the semester, and that is physiology of the male reproductive system. Physiology of the male reproductive system. Previously, we dealt with the anatomy of the male and female reproductive system. So now, with the physiology, we'll be looking at the various structures that we saw in the anatomy lesson, what those structures do, their main roles and functions in the body. We also saw some glands producing hormones. What do the hormones specifically do? This physiology lecture will also encompass some areas like pathways into sperm production. We'll also be looking at how the glands are produced and their functions. Then we'll look at various cells and tissues. Then I would like to state very clearly that there are some repetitions of the anatomy lecture in this physiology lecture. So when I see those anatomy lecture key points resurfacing this physiology, I'm not going to explain them because time is not really on our side. So, but for the expedition of time, we would like to zero in on this lecture, physiology of the male reproductive system. Then tomorrow or the next week, we will tackle physiology of the female reproductive system. So we are going to look at the male reproductive system, the various organs, the glands, their functions, and how the structure relates to function. So, please, if you have not been part or watched the lecture on the anatomy of the male and female reproductive system, then definitely you need to go back to that lecture so that it will help you, because if you jump in onto this physiology lecture, you will miss a whole lot of lectures of the previous, a whole lot of lessons from the previous lecture. So there are some images I'm not going to explain because I've already dealt with it in the previous lecture. So I'm supposed to do that to waste our time. Please stay tuned as we go to classroom to start a lecture on the physiology of the male reproductive system. Thank you. Physiology of the male reproductive system. So we'll be looking at sexual reproduction development in males, male reproductive anatomy, puberty and climacteric. Okay, so a climax of this thing, what do we call it? Puberty and climacteric, that climax of the it's like menopause. Menopause in males is called andropause. So climacteric is synonymous to andropause over here. Then we'll be looking at the sperm and its production, male sexual response. Okay, so by way of continuation, the male reproductive organs include primary sex organs and accessory sex organs. And the primary sex organs are the testes, or what we call the gonads in males. Accessory sex organs in males are the seminal vesicle, the prostate gland, the urethra, and the penis. External and internal genitalia. So within the male reproductive system, which ones are exposed to the environment and which ones are buried within the pelvis or the pelvic area? So let's see. Reproductive organs are generally classified into two groups, namely external genitalia, that are genital organs, and internal genitalia. Genitalia means genitals. External genital organs in males are the scrotum, the penis, and the urethra. And the remaining sex organs constitute the internal genitalia. So let's see. So you can see the scrotum is outside the body, the penis and the urethra are outside the body, so they are external. Whereas the vast difference, the what we call the prostate and the rest, they are buried within the pelvic area, so they are internal. So let's see, we saw this image in the anatomy class, so I'm not going to touch on it. So external genitalia of the male, the scrotum and the penis, they occupy the perineum. And the perineum is a diamond-shaped area between the thighs, bordered by the pubic symphysis, ischial tuberosities, and the cortex. So let's see. So you can see over here the diamond area. This diamond, there are two triangles here. We have the urogenital triangle and the inner triangle. So this is the inner triangle bordered. And this is the urogenital triangle because that's where urine is produced. So these two triangles put together gives us a diamond shape. And this diamond shaped area, all this area is called the perineum. The pouch, the scrotum is the pouch of skin, muscle, or fibrous connective tissue containing the testis. This is the scrotum houses the testis. In our previous lecture we saw it. The left testicle usually descends lower than the right so that the two are not compressed against each other. I earlier on explained. So you can see that the left testicle is lower. It's of a lower, it descends down, or it's longer than this one, so that they don't rub against, the two testicles do not rub against each other. The skin has sebaceous glands, sparse hair, rich sensory innervation, and somewhat darker pigmentation than the skin elsewhere. So the skin on the scrotum is darker than all the skin elsewhere, and it scarcely has hair. The hair is not much. It has a rich sensory sensation. A small touch, it feels it. Then has sebaceous glands to produce the scent. Internal medial septum divides scrotum into right and left compartments. So we can see the internal medial septum. So this is the septum. Also, it's part of the perineal rapid. So internal medial septum is here. Internal medial septum. Okay, it's missing. Okay, so let's see. Medial septum of scrotum. So this one, medial septum of scrotum. When this scrotum has been cut, transversely cut. So this is the septum. There's a septum that separates so that this testis will not touch this testis. The spermatic cord here, the spermatic cord here will not touch this. So they are in separate compartments, separated by what? A partition called internal medial septum. Okay? Okay. Perineal raphe, medial seam located on the scrotum extending anteriorly along ventral side of penis and posterior to anus. So this is the perineal raphe. and that's the explanation. It extends from the penis to over here, perineal rapid. And it also goes to the anus. Okay, what is the spermatic cord? It's a bundle of fibrous connective tissue containing the ductus deferens or vas deferens, blood and lymphatic vessels, and the testicular nerve, also called genitofemoral. It continues through 4 cm inguinal canal into the pelvic cavity. We have the external inguinal ring and the internal inguinal ring. The human testes reside in the scrotum because they have adapted, or this scrotum has been adapted to cooler environment, meaning that in the scrotum, sperm cannot be produced at a physiological temperature of 37 degrees. It must be produced at a lower temperature of 35 degrees. So the scrotum is a cool environment that the testes have been housed to be able to produce the semen at a very low temperature. So if the testes were buried in the body, like something we call cryptorchidism, which we will see later, the testes have been buried in the body, the physiological temperature of 37 degrees will affect semen production. So that's why God thought it wise to bring the testes into the scrotum, which hangs outside the body, so that it can have a cool environment or cool temperature, lower temperature. So let's see the inguinal rings. So this is the opening of what? The inguinal canal. So this whole thing, the inguinal canal, is a hole where the spermatic cord and the rest, genitofemoral nerve or the testicular nerve, the blood vessels, what do we call it? Testicular artery, testicular vein, they all pass there. Vas deferens also passes through this inguinal canal. In the inguinal canal, the entrance of the inguinal canal is called deep inguinal ring. Then the exit is called superficial inguinal ring because it's towards the outside, but the deep inguinal ring is towards the pelvic area. It's buried inside the pelvic area, but the superficial is coming out, like the way the scrotum has come out of the body. So we have the superficial inguinal ring and the deep inguinal ring. Okay, scrotum has 3 mechanisms to regulate temperature of the testes. We have the cremastaris muscle, which strips off the internal abdominal oblique muscle and emits the spermatic cord. So therefore, in cold temperatures, the cremastaris muscle contracts and draws testes upwards towards body. So when the environment is very cold, the cremastaris muscle draws testes upwards towards the body. In warm temperatures, the cremastaris muscle relaxes, suspending testes further from the body so that it will not encounter the heat of the body. There is also the darkus muscle, which is subcutaneous layer of smooth muscle, which contracts when it is cold, wrinkling the scrotum, holding testes against warm body. So it contracts when it's cold and becomes wrinkled, so that it will hold testes against warm body. When it also wrinkles, it reduces the surface area, or reduces the surface area of the scrotum, and by this it reduces heat loss. So you can see that when the temperature is very cold, your testis wrinkles. It becomes very small and wrinkled, so that it will conserve heat. But when the temperature is very, very hot, the wrinkling ceases. The testis is held outside the body, so that it will not touch the pelvic area where it is hot. So you see that the testis will now become like big, released, so that the surface area can now absorb more cold instead of heat. So let's go and see the let's go and see. Okay, so we continue. So let me go and explain. Okay, so we have the cremaster muscle here. That when the weather is hot, is able to be relaxed or pull down the testis, so that it will get cold temperature. But when the weather is cold, it will contract the testis upwards to against the body, or towards the pelvic area of the body, so that it can be able to absorb some heat from the body. The same way, this is the dartos muscle. In the dartos muscle also, when the weather is cold, it wrinkles the scrotum, so that then it will now, after wrinkling the scrotum, it will draw it upward towards the body to absorb some heat from the body. And the vice versa occurs when it is warm, because when it's warm, it doesn't need to be attached to the body which is cold, but has to be drawn outward. So you know the testis needs a cool environment to be able, about 34 degrees to 35 degrees or 33 to 35 degrees, to be able to produce sperm, because sperm at 37 degrees, all the sperms will die. They can't stand the hot temperature. So that's why there is something we call the gaseous exchange. Gaseous exchange. There is something we call the what we call, we will get there. Just let's get there. So there is okay, so we have the pampiniform plexus. It's an extensive network of veins from the testis that surrounds the testicular artery and spermatic cord. So there is counter-current heat exchanger. So without the pampiniform plexus, warm arterial blood will heat the testis and inhibit sperm production. So let's see. So pampiniform plexus removes heat from the. So without the pampiniform plexus, warm arterial blood will heat the testis and inhibit sperm production. So the pampiniform plexus removes heat from the descending arterial blood. By the time it reaches the testis, the blood is 1.5, or the blood is lesser in heat by about 1.5 to 2.5 degrees C. So let's see what I'm talking about here. So this is the countercurrent heat exchange system. So this is the spermatic vein and the spermatic artery. So it forms a network called pampiniform plexus. So over here, testicular vein is here, testicular artery is here. The veins are of a lower temperature because they are now ascending so that they can get to the inferior vena cava. But the testicular artery is of hot temperature because it's just coming from the heart through the internal iliac, the external common iliac, or the abdominal aorta. So we can see over here that the veins carry blood which is of a lower temperature, 33 degrees, and the artery carries 34 degrees. So the blood in the artery needs to be cooled down. So let's see, from the pelvic area, we can see a 37 degrees Celsius blood is flowing from the testicular artery into the testis. This is the testis, the destination is the testis. So the arterial blood cools as it descends. Why? Because it is opposed to or attached to the testicular veins. So as it's attached to the testicular veins, the heat, the testicular veins are of a lower temperature, it's cooler. While the artery is 37 degrees, the veins are lesser than 35 degrees. So they will absorb the heat from the arteries. Then when they absorb the heat, they will flow out of the pelvic, while the arterial blood goes into the testis. So the blood from 37 degrees, the blood from the artery now reduces to 35 degrees, which is conducive for sperm production. I've explained this diagram already in the anatomy class, so I will not go there again. This one do the same. Okay, so the testis is a combined endocrine and exocrine gland. That means that it produces sex hormones and sperm. This is its dimension. The tunica albuginea, which is white fibrous capsule on the testis, is a connective tissue septa. It's a white fibrous capsule on the testis. A connective tissue septa divides testis into 250 to 300 wedge-shaped lobules. Seminiferous tubules. Okay, so let's see. Okay, so we have the seminiferous tubules, that is inside those seminiferous tubules. We have two in this lobule. And a septum separates. This is a septum. It separates one lobule from another. So all this is a seminiferous lobule. This one contains, all this is a lobule, contains about 3 lobules. This one contains 2 seminiferous lobules. This one contains 2. This one contains 3. So you can see the lobules have been folded. It's a tube in which sperms are produced. So we can see the tunica vaginalis, where I said previously that when somebody has hydrocele, that is abdominal fluid collecting in the scrotum, the fluid is collected in the tunica vaginalis. The tunica albuginea is like egg, is a tissue which is like egg white. That covers the whole of the testis. Then we have the epididymis at the back of the testis. Okay, so we have the vas deferens also. Okay, so this I've explained the lobule and the seminiferous tubule. Let's go back. Okay, so tunica albuginea is a white fibrous capsule on testis. Connective tissue septa, that this is what separates or divides the testis into 250 to 300 wedge-shaped lobules. Seminiferous tubules, 1 to 3 in each lobule. Each tubule is lined with a thick terminal epithelium for sperm generation. We will see this later. Leydig cells, which are also called interstitial cells, are located between the seminiferous tubules, and these Leydig cells produce testosterone. Then sustentacular or Sertoli cells, which are located between the germ cells within the seminiferous tubules, protect the germ cells and promote their development. The sustentacular cells or Sertoli cells also provide nutrients, remove waste, and also growth factors and other needs of the germ cells. So let's go and see what is happening here. Let's go. So let's see. Okay. Okay, so this is the diagram I'm looking for. Spermatogenesis, we will come back there. So we have, this is a basement membrane, type A spermatogonium. It is an immature sperm cell producer. So immature sperm cell, a precursor of sperm cell. Okay, so we'll get there, but I want you to see the Leydig cell. So this is interstitial or Leydig cell, and this whole structure is a seminiferous tubule. This one is a seminiferous tubule. This one is a seminiferous tubule. But the Leydig cells are between these two, or they are located between seminiferous tubules, and they are also called Leydig cell or interstitial cells. Whereas tentacular cells are located within the seminiferous tubules. They are also called Sertoli cells. And you can see spermatis over here. Blood vessel, seminiferous tubule itself. The seminiferous tubule dimension is from here to here. So you can see the whole structure is a seminiferous tubule. Then these ones are germ cells. They produce the sperms. So you can see a micrograph, electron micrograph of this same thing. This whole structure is a seminiferous tubule. It's a tubule, and when the cells are produced, they come into the lumen or the hole. They come and attach to the hole because they are ready to be released into the epididymis. So you can see over here. This is the basement membrane of the seminiferous tubule. That's outside. The basement membrane is the covering of the seminiferous tubule. Then these are cells. Then this strata is the hole or the lumen. So you can see attached to the basement membrane is type A spermatogonium. Then we come to a tight junction which is formed by the testicular or Sertoli cells. We come to type B spermatogonium, primary spermatocyte, because this type A spermatogonium will now mature to type B spermatogonium, will now divide. Will divide so that we have type B spermatogonium, and the type B spermatogonium, the type A spermatogonium will remain, and the type B spermatogonium will go and become a primary spermatocyte, which will divide by meiosis 1 to 2 daughter cells, and the 2 daughter cells will go to meiosis 2, and divide into 4 daughter cells, and these 4 daughter cells are now undergoes a process of maturation, that's spermiogenesis, to produce the sperm. So let's go back. We haven't started spermatogenesis. We'll come and start it. So I've explained the function of the Leydig cells between tubules produce testosterone. Leydig cell produce testosterone. So testicular cells, that's what I showed you. The germ cells depend on them for nutrient waste removal, growth factors, and other needs. So the seminiferous tubules are thread-like, convoluted tubular structures that produce spermatozoa or sperms. So I've shown you the structure of the seminiferous tubule, and that's where that is what produces the spermatozoa or sperms. Each testis contains about 400 to 600 seminiferous tubules. Each tubule is 30 to 70 centimeters long with a diameter of 150 to 300 microns. So let's see. This is let me show you the diameter of the tubule. So this is the diameter of the tubule from here to here. From here to here is the diameter, and the length here we can't see because this is a cross section. The diameter from here to here is the diameter, or from here to here is the diameter, but the length you can't see is a cross section. Okay, so layers of the seminiferous tubule. The seminiferous tubule has an outer capsule or tunica propria formed by fibroelastic connective tissue. It also has thin homogeneous basement membrane complex stratified epithelium which consists of two types of cells. We have the spermatogenic cells, or cells that produce the sperm, which is also called germ cells, and the Sertoli cells. So the spermatogenic cells are the primary. We have the types of spermatogonias. We have the, let's see, the spermatogonias. So we have the type A spermatogonium is a germ cell. Type B spermatogonium is a germ cell, or spermatogenic cell. They lead to the production of sperm. But these ones here, these yellow ones here, which form the tight junctions, they are the Sertoli cells. Okay, so let's see the types of epithelial cells. We have simple squamous epithelium. It looks like this. Then simple cuboidal. The cells are cuboid in shape. Simple columnar. The cells look like a column. Then if we say stratified means that we have more than one type of epithelial cells clustered together, and this forms a stratified epithelium. So if we have more than one squamous cells clustered together, we can see one layer here, one layer here, one layer here, one layer here, one layer here. We call it stratified squamous epithelium. This is a stratified because more than one epithelial or simple epithelium put together. So we have stratified cuboidal epithelium. We have pseudo stratified columnar, meaning that it doesn't look like a column cells. The cells do not look like column. They look like column, they didn't look like column, and that is what occurs in most of the parts of the body. Then we have transitional epithelium. Transitional means that if the epithelial cells are stretched, or if the epithelial tissue is stretched, you can see that it will change from maybe cuboidal or columnar to a cuboidal, or it can change from cuboidal to columnar. Then if it is relaxed, it can change to another epithelial type of cell. So this is what occurs in the urinary bladder. When it is full, when it is relaxed, it can be cuboidal. When it is full, it becomes columnar. And columnar epithelial cells are what are located in mucous membranes, and they secrete mucus. So let's look at that. And the simple squamous or the squamous or stratified epithelium are located at where areas in the body where we have wear and tear, a lot of friction, like the anus, like the vagina opening, like the mouth. Wherever there is wear and tear and the body needs to be so strong, or tissues needs to be so strong at that place, we have the squamous epithelium there. So this is just a revision of what we did in histo in pathology. So spermatogenic cells or germ cells present in seminiferous tubules are precursors of spermatozoa. So I showed you, and I showed you that the Sertoli cells are arranged in orderly manner in 4 to 8 layers. In children, however, the testis is not fully developed. Therefore, the spermatogenic cells are in a primitive stage called spermatogonia. With the onset of puberty, the spermatogonia develop into sperms through different stages. So, stages of spermatogenic cells. We have the spermatogonium, primary spermatocyte, secondary spermatocyte, and the spermatid. So let's go and see the stages of spermatogenic cells. So the stages of spermatogenic cells, we have the type A spermatogonium, type B spermatogonium, which now goes matures into primary spermatogonium. So type A spermatogonium will divide into two, and one will become type B spermatogonium, and one will be left behind. Then the type B spermatogonium will mature to primary spermatocytes, which will now divide by meiosis 1 into two daughter cells. The meiosis, each of these two daughter cells will now divide into two, giving us four daughter cells, which will undergo spermiogenesis or maturation to produce sperm at the lumen of the seminiferous tubule. So that's what we have. Okay, so we have, okay, so I've explained spermatogonium becoming primary spermatocyte, secondary spermatocyte, and the spermatid. Sertoli cells are the supporting cells for spermatogenic cells in seminiferous tubules. So Sertoli cells support the spermatogenic cells, that's the spermatogonium, type A spermatogonium, type B spermatogonium. They are large and tall, irregular columnar cells. I've shown you how columnar cells look like, extending from the basement membrane to the lumen of the seminiferous tubule. Germ cells present in seminiferous tubules are attached to Sertoli cells by means of cytoplasmic connections. This attachment between germ cells and Sertoli cells exists till the mature spermatozoa are released into the lumen of the seminiferous tubule. So I've explained this. The Sertoli cells function by supporting and nourishing spermatogenic cells. So the spermatozoa are released from them. The Sertoli cells are very important. They provide nutrients, remove waste, support the spermatogenic cells. That's the type A spermatogonium and type B spermatogonium and the rest. The Sertoli cells secrete enzyme called aromatase, which converts androgens into estrogen. Very important. The Sertoli cells release enzyme called aromatase. Sertoli cells secrete androgen binding protein, which is essential for testosterone activity, especially during spermatogenesis. So Sertoli cells also produce androgen binding protein, which is essential for testosterone activity, especially during spermatogenesis. Sertoli cells secrete estrogen binding protein. They also secrete inhibin, which inhibits FSH or follicle stimulating hormone released from the anterior pituitary. We'll see all this in the next slide. Sertoli cells secrete activin, which increases follicle stimulating hormone release. Sertoli cells also secrete Mullerian regression factor or anti-Mullerian hormone or anti-Mullerian hormone, which is also called Mullerian inhibiting substance. And this hormone is produced by Sertoli cells in male fetuses, and this is what signals the regression of Mullerian duct, fallopian tubes, and the uterus. So if these hormones are not produced in required quantities in males, then you will see a male becoming kojobesia. You see a male having fallopian tubes, a male having uterus, a male having vagina and becoming hermaphrodite, because this hormone has to be secreted in high quantity so that it can regress or depress Mullerian duct, fallopian tubes, and the uterus, vagina, and the rest from forming in a male. So if you go to a hospital and you are a woman, they will let you do, and you are screening for infertility, they will let you do AMH. It is also called MRS or MRF. The doctor will write it for you. It's very, very expensive, because the doctor wants to know whether you, as you have come as a woman and you want to deliver, you have some high levels of androgens or male factors. Do you have a whole lot of things, whether your physiology is dominated by male hormones and the rest. So you need to do the AMH. So descent of testes. Both male and female gonads initially develop high in the abdominal cavity, near the kidneys. And kidneys are located in the abdomen. And they don't descend after birth. But the testes are also produced in the abdomen, but they need to descend into the pelvic cavity. Apart from the testes, the ovaries are also produced in the abdominal cavity and needs to descend into the pelvic cavity. So there's a structure called gubernaculum. It's a connective tissue cord that extends from the gonad to the floor of the pelvic cavity. So this is a sensor or something that senses or guides the testes or the ovaries to the scrotum. I think scrotum we'll see very soon. So in female, the gubernaculum becomes the ovarian ligament. By males, it becomes small and attaches to the scrotum. So let's see this. So you can see here the gubernaculum is here. In a 3-month fetus, that's a fetus inside the womb. You can see the parietal peritoneum, the epididymis, the testis, tarsal deferens. I've explained this one previously. The vaginal process is a protrusion of the abdomen into the pelvic area. So you have the gubernaculum going to the scrotal swelling or the floor of the scrotum. By 8 months, this vaginal process, or which is a part of the abdominal tissue, is supposed to descend down the testis, down the scrotum, and the testis is supposed to descend. It's in the abdomen, it has to descend to the scrotum, so it's descending. Then 1 month after birth, the testis fully enters the scrotum. Then this process, vaginalis or vaginal process, is closed, so that there will not be any connection between the vaginal process or the abdominal remnant in the testis and the one in the abdomen. It should be closed. If it's not closed, that is what brings about inguinal hernia. So the vaginal process is the fold of the peritoneum that extends into the scrotum, that's the abdominal, the peritoneum of the abdomen. Okay, so inguinal canal is the pathway of low resistance to the groin, created by gubernaculum and the vaginal process. Most common site of herniation in boys and men, that's inguinal hernia. So let's see. I showed you the inguinal region. So this is the inguinal canal. The inguinal canal. Inguinal canal, inguinal canal. Okay. So this whole thing is the inguinal canal. Inguinal canal. You can't see with your eyes, it's the fold of the peritoneum. So this is the inguinal canal, where the testicular arteries, testicular veins, vas deferens, they all enter spermatic cord and testis. So okay, so descent of the testis. So descent of the testis begins as early as 6 weeks, because in 7 months, testis abruptly pass through the inguinal canal into the scrotum, gathered by the gubernaculum. Testis accompanied by elongating testicular arteries and veins, lymphatic vessels, nerves, spermatic ducts, and extension of internal abdominal oblique muscle. Cryptorchidism It is a condition in which boys are born with undescended testes, that the testis remains in the peritoneum, in the abdomen, and this occurs in 3% of male births. Most cases, the testis descend during the first year of infancy. If it does not descend during the first year of infancy, testosterone injection is given to cause it to descend. If by this is not testosterone injection is given, or else you can also do a simple surgery to draw the testis into the scrotum. If it is uncorrected, this will lead to sterility or testicular cancer, because testis is not supposed to abide in the abdomen, because the abdomen has physiological temperature which is high. It's 37 degrees, and you know testis cannot survive such a high temperature. It has to be around 34 degrees to 35 degrees. So it will lead to testicular cancer, because that's not where it's supposed to be in the body. It's supposed to be in the scrotum, and the scrotum has a cool temperature. So this will lead to either sterility or infertility or testicular cancer. Let's pause our lecture here for the next